Welcome back to the deep dive. You know the drill. You bring the cool stuff and we unpack it.
Yeah.
Wow. This time you guys have really outdone yourselves.
Some amazing sources this time.
So if you love these deep dives, be sure to like and subscribe to the channel. It helps others discover the show and you'll never miss an episode.
Right.
Okay, you ready for this one? We're diving into a scientific mystery.
Buckle up.
That could rewrite what we know about Earth's history.
Big stuff.
Oceans. Even the possibility of life beyond our planet.
Yeah.
We're talking about small comets or megacriometeors.
Aren't they sometimes called?
Research articles, eyewitness accounts.
Yeah.
Even some declassified government documents.
Uh-huh. This isn't just some fringe theory. This
Right.
is evidence from multiple spacecraft radar observations.
Wow.
Some of this is even top secret.
So the big question is, are we constantly bombarded by tiny comets we can't even see?
That's right. And if so, where did all this water come from?
Okay.
I mean, did our oceans actually come from space?
Right.
To understand this whole thing, we need to go back to the 1980s
Right.
and meet a scientist named Dr. Louis Frank,
Okay.
a respected space physicist who stumbled upon something really puzzling
Right.
while analyzing satellite images.
Picture this. Dr. Frank's looking at images of Earth's upper atmosphere from NASA's Dynamics Explorer 1 satellite.
Right.
And he keeps seeing these weird, dark spots.
Yeah.
At first, everyone thinks it's just a technical glitch.
Of course, that's the first thing you'd think.
Yeah.
But Frank, being a thorough scientist, he went through every single possible explanation, tested the instruments, checked the data transmission systems, you name it.
Yeah, wow.
He was determined to prove that it was an error.
Okay.
But it wasn't.
It wasn't.
So here's where it gets wild.
Okay.
After ruling out every other possibility,
Yeah.
Frank's team was left with the truly mind-blowing conclusion.
What is it?
These were massive clouds of water vapor,
Okay.
far larger than any known meteor,
Oh.
entering the atmosphere.
Really?
The only thing that could explain it was
Yeah.
comets. But not the kind we usually think of.
Not like Halley's Comet.
Right.
Okay.
These weren't these massive fiery comets like Halley's Comet.
No.
Frank's calculations suggested these were much smaller,
Okay.
maybe the size of a house,
Wow.
composed mostly of ice.
Uh-huh.
He called them small comets.
Small comet.
And the scientific community, well, let's just say, they weren't exactly thrilled with this idea.
I can imagine.
It's like telling everyone the sky is actually green.
Right.
It's just this total upending of what we thought we knew.
So why all the pushback? Was it just the idea of comets hitting Earth?
Well, there was already some resistance to the idea that Earth isn't totally isolated from
right.
cosmic events.
Okay.
The prevailing wisdom was that we're pretty much untouched
Okay.
by stuff happening out in space.
Yeah.
But Frank's claim that these small comets were hitting us constantly
Right.
at a rate of tens of thousands per day, that was just seen as outrageous, almost heretical.
So it's not a little sprinkle of space ice?
Yeah.
It's a full-on cosmic blizzard.
A deluge.
No wonder people were skeptical.
Yeah.
But Frank wasn't backing down.
No, he wasn't?
He doubled down and started looking for more evidence to support his theory.
Exactly.
Yeah.
Frank wasn't the type to be intimidated by naysayers.
Yeah.
He was convinced he was onto something huge,
Huh.
something that could change our entire understanding of Earth's history.
Okay.
So he started digging deeper.
All right.
And this is where the story gets even more fascinating.
Okay.
One of the biggest mysteries about Earth has always been the origin of its oceans.
Yeah. Where did all that water come from?
Right. You always hear about Earth being
This hot molten ball of rock.
Exactly, this hot molten ball of rock early on.
Early on. Yeah.
So how did we end up with enough H2O to cover over 70% of the planet's surface?
So volcanoes, right.
That's usually the explanation.
Yeah.
The traditional theory is that Earth's water was trapped within the planet's interior
Uh-huh.
and released gradually through volcanic activity.
Okay.
But there's a problem with that.
What's that?
The chemical composition of Earth's oceans doesn't quite match what we'd expect if all the water came from Earth itself.
Hold on. So you're saying there's something off about our water?
Yeah.
Like it has a funky taste or something?
Not quite. It's more about the specific elements present in the water.
Okay.
Scientists found what they call an excess of volatiles, things like hydrogen,
Uh-huh.
nitrogen, and carbon,
Okay.
that are more commonly found in, you guessed it, comets and asteroids.
Oh, okay. So now things are starting to click.
Right.
So Frank's thinking is If Earth's water isn't quite Earth-like,
Yeah.
maybe it came from space, delivered by a steady bombardment of these little icy comets.
Exactly.
Over billions of years.
Over billions of years, that's exactly it.
Wow.
He even pointed to studies of Halley's Comet, which found that its chemical fingerprint was remarkably similar to that of Earth's oceans.
Really?
It's like finding a cosmic water bottle with a label that says, "Made in the Oort cloud, enjoy on Earth."
Now, that's what I call compelling evidence.
Right.
But hang on a sec. If we're talking a constant barrage of these mini comets,
Yeah.
wouldn't we see evidence of them hitting other things too?
Like
the moon, for instance.
the moon.
It's right there. It's been around just as long.
Yeah.
Shouldn't it be covered in craters from these icy impacts?
That's a great point, and one that Frank's critics were quick to bring up.
Yeah, it seems like an obvious objection.
It does.
If Earth's getting hit, the moon should be too.
Right. But here's where things get really interesting.
Okay.
The answer lies in what those seismometers left on the moon by the Apollo astronauts actually detected.
Okay, the Apollo missions. So we're talking actual hard data from the moon.
Hard data.
Not just speculation.
Yep.
What do those seismometers tell us?
Well, if you do the math based on Frank's estimated rate of small comet impacts on Earth, and assume they hit the moon like solid rocks, we should have seen a lot more impacts than the seismometers recorded.
Ah.
A lot more.
Interesting.
The moon wasn't ringing like a bell the way it should have been.
So it's like the moon should be a cosmic gong, but it's more like a muffled drum.
Yeah. Something's not adding up.
So how did Frank explain this?
He had a clever explanation. Think about it. A rock hitting the moon makes a very distinct seismic signal.
Think.
Bang. But a snowball, even when traveling at high speed, would be more like splat.
Splat.
That kind of impact wouldn't create the same strong seismic waves.
Interesting.
So it's likely those impacts were just going unnoticed.
That makes sense. It's the difference between throwing a pebble into a pond versus a giant snowball.
Right.
The ripple effect just isn't the same.
Exactly.
But is there any evidence to back up this splattering comet idea?
As a matter of fact, there is. Frank pointed to this fascinating observation from 1985.
Wow.
A group of Greek astronomers captured this strange, short-lived flash on the lunar surface, and it couldn't be explained by any known lunar phenomenon.
Really?
So Frank's argument, it was a small comet exploding on impact.
Okay, that's two pieces of evidence supporting Frank's theory.
Yeah.
We've got the chemical makeup of Earth's oceans and this unexplained lunar flash.
Yep.
But you mentioned top-secret documents earlier.
I did.
What's that all about?
Frank wasn't just relying on observations from Earth and the moon.
Okay.
He was also looking at data from other spacecraft, including classified military satellites.
Oh, wow.
Designed to detect nuclear explosions.
Now we're talking spy stuff.
Yeah.
I'm all ears.
Interestingly enough, these satellites, which were super sensitive to any kind of energy bursts in the upper atmosphere, they were detecting something that looked a lot like, you guessed it, small comet impacts. But this information was highly classified at the time.
Oh.
So Frank had to fight tooth and nail to get access to it.
So not only was he battling scientific skepticism, but government secrecy, too.
It was a fight.
This Dr. Frank sounds like a real maverick.
He was.
But wait a minute. We've got oceans.
Yeah.
We've got the moon. We've got spy satellites. What about evidence here on Earth? Shouldn't there be something more concrete?
What do you mean?
I mean, it's something we can actually see.
Visual confirmation?
Yeah.
That would be the holy grail, wouldn't it?
Yeah.
And that brings us to the story of another scientist.
Okay.
Clayne Yates and his quest to capture those elusive small comets on camera.
Okay, so we're going from the world of classified data to actual pictures.
That's right.
All right, I'm ready for this. Tell me more about this Clayne Yates character.
Okay.
And his comet hunting adventures.
So Yates was working with this well-known astronomer named Tom Garrels at the University of Arizona, and they had access to this incredible telescope called Spacewatch.
Spacewatch?
Yeah.
That sounds impressive.
It was designed to spot faint objects in the night sky.
So Yates decided to use this high-tech telescope to go after Frank's small comets.
He did.
Was Garrels on board with this plan?
Well, interestingly enough, Garrels himself was skeptical of Frank's theory.
So even though Garrels was a skeptic, his own colleague was on Team Small Comet.
It's true.
That's got to make for some interesting office conversation.
Yeah. I imagine.
But Yates, being a persistent scientist, managed to convince Garrels
He did?
to let him use the telescope
Yeah.
to look for these elusive objects.
Yeah, he even developed a special technique to try to capture them on film.
I'm guessing these weren't the kind of picture-perfect comet images you see in textbooks.
No.
These things are tiny, right?
Exactly. Yates knew he wasn't going to see this perfectly formed comet tail or anything like that.
Oh.
Instead, he focused on capturing their movement.
Hmm.
He took super short exposures, fractions of a second.
Wow. And then looked for faint streaks of light that moved across the sky in a specific way, the way Frank's small comets were predicted to move.
So it's like trying to photograph a hummingbird's wings. You're not looking for the bird itself, but the blur of motion.
That's a great thing.
Pretty clever. And what did Yates find? Did he capture any of these streaks?
He did, and this is where things get really, really interesting.
Okay.
Yates's images showed these faint, fleeting streaks that perfectly matched the predicted movements of small comets.
Wow, so this is like the smoking gun.
Yeah.
Pictures from a reputable observatory using a technique specifically designed to spot these things.
Yeah.
Surely this convinced everyone, right?
Well, not exactly.
Yeah.
Even with these intriguing images, the scientific community was still divided.
Really?
Some remained staunchly skeptical,
Oh, wow.
while others were starting to see Frank's theory in a new light.
Okay.
And as we'll see this back and forth,
This battle between skepticism and open-mindedness
Uh-huh.
is a recurring theme in this whole small comet saga.
Okay, you've definitely piqued my curiosity.
Yeah.
It sounds like we're just scratching the surface of this mystery.
Oh, yeah.
Let's take a closer look at the opposition Frank faced,
Okay.
because it seems like he had to overcome some serious hurdles to even get his research published.
You're absolutely right. In fact, Frank's experience
Yeah.
is a perfect example of how groundbreaking discoveries often face this uphill battle, especially when they challenge these deeply held beliefs
Right.
and threaten to overturn established paradigms.
You know what they say the truth is out there?
It is.
But sometimes it takes a real fight to bring it to light.
That's for sure. You know, it's fascinating how often in science, big breakthroughs
Yeah.
are met with resistance,
Right.
almost like a knee-jerk reaction.
Uh-huh.
It makes you wonder, what other groundbreaking ideas might be out there just waiting for the right moment to be accepted.
Yeah, it's like we as humans have this built-in fear of the unknown, even in the scientific world.
Absolutely. And one of the sources you shared, startling discoveries and contrarian anomalies, small comets, and the role of paradigm resistance in science
Yeah.
really dives deep into this.
Oh, yeah, that article was a real eye-opener.
It highlights how paradigm shifts in science, those moments when our fundamental understanding changes.
Uh-huh.
They often face fierce opposition.
Yeah, it talked about Alfred Wegener, the geophysicist,
Well, yeah,
who proposed the theory of continental drift.
of course.
Imagine that the idea that continents move around like puzzle pieces
Right.
was once considered crazy.
It was ridiculed.
Right.
Wegener's idea that the continents were once joined together
Yeah.
and have slowly drifted apart over millions of years was initially just dismissed by the entire geological community.
Wow.
It took decades for his theory to gain widespread acceptance.
Makes you think, doesn't it?
It does.
What we consider common knowledge today might have been a radical, even heretical idea just a few generations ago.
Absolutely. It's a reminder that science is a constantly evolving process, always open to new evidence and new interpretations.
But changing deeply held beliefs, even in the scientific world, can be a real struggle.
It can.
It's like that saying, science advances one funeral at a time.
Oh, wow.
Sometimes it takes a whole generation to pass
Yeah.
before new ideas can really take hold.
That's a bit morbid, but you're not wrong.
Yeah.
And speaking of challenging these deeply held beliefs, the article also mentioned Peter Duesberg,
Yes.
a prominent virologist who questioned the link between HIV and AIDS.
Yeah. That sparked a huge controversy.
It did. It's still a touchy subject even today.
Yeah, but Duesberg's story and the backlash he experienced
Right.
shows just how difficult it can be to go against the grain,
It can be tough,
even when you have compelling arguments.
even when you have really good points.
And that brings us back to Dr. Frank
Right back to Dr. Frank.
and the storm of controversy surrounding his small comet theory.
According to his book, The Big Splash, the reaction from some corners of the scientific community was, let's just say, less than welcoming.
From what I read, some folks didn't just disagree with him.
No, they didn't.
They went on the attack.
They did.
Rejected his papers without even reading them, publicly ridiculed his work, even accused him of being incompetent.
It was rough.
It was a rough time for Dr. Frank.
He recounts how some scientists just refused to consider the possibility that he might be right.
Wow.
No matter what evidence he presented. They were so attached to the existing paradigms, the accepted explanations, that they just couldn't see the world in a new way.
It's like they had these scientific blinders on.
Yeah.
Blocking out anything that didn't fit their worldview.
It's a shame because Frank's work wasn't just some wild speculation.
Right.
He was backing up his claims with data, with observations, with this rigorous scientific process.
But even in science, sometimes it's not enough to be right. You also have to be persuasive, right?
You do. And Frank, despite his brilliance, wasn't always the best at playing the political game of science.
Whoa.
He was more interested in pursuing the truth wherever it led than in winning popularity contests.
So I guess that makes him a true scientific rebel.
I think so.
But even rebels need allies.
They do.
Did anyone come to Frank's defense during all this?
He did find support from some unexpected places.
Okay.
There were other scientists, perhaps less bound by the prevailing paradigms, who were intrigued by his findings and willing to at least consider the possibility that he might be onto something.
The article mentioned a scientist named Tom Donahue.
Tom Donahue.
Who, ironically, was a vocal critic of Frank's work early on.
He was.
But then he stumbled upon his own evidence for cometary objects in the inner solar system.
He did. What a plot twist.
That's quite a plot twist.
Donahue was studying data from the Voyager spacecraft, looking for signs of interstellar hydrogen, when he found something completely unexpected.
What's that?
This huge cloud of hydrogen surrounding the sun.
Wow.
Right here in Earth's neighborhood.
So the guy who was arguing against Frank's small comets finds evidence for more comets.
It's pretty ironic.
That's got to be awkward.
It was.
So Donahue, based on his findings, proposed the existence of cometesimals.
Cometesimals.
They were a bit different from Frank's small comets.
A little bit.
But still objects made of water ice.
Right.
Originating from the outer solar system.
Exactly.
So we go from Frank being this lone wolf
to
having another respected scientist, a former critic no less,
suggesting
that, hey, maybe there are a lot more icy objects zipping around the inner solar system than we thought.
That's right.
That's got to be a win for Frank.
It was a big win for Frank. It gave his theory some credibility.
Yeah.
And even though Donahue and Frank still disagreed on the specifics, the fact that another scientist was proposing a similar idea really helped shift the conversation. It was no longer just Frank against the world.
Strength in numbers.
Exactly.
But if I remember correctly, this scientific bromance didn't last too long.
Sadly, no.
What happened?
As is often the case when you have a new discovery that threatens to shake things up, the competition can get fierce.
Yeah.
And in this case, the rivalry between Donahue and Frank ultimately led to this big falling out. There was a lot at stake, especially with the Galileo mission to Jupiter on the horizon.
Oh, yeah. Galileo, that was a big deal back then.
It was huge.
How did that mission get tangled up in this whole comet controversy?
Well, Galileo, which launched in 1989, was designed to study Jupiter and its moons.
Right.
But it also had these instruments capable of detecting hydrogen in interplanetary space.
Oh, wow. Okay.
Both Donahue and Frank knew that Galileo's data could be the key to proving or disproving their theories about comets in the inner solar system.
So it was a high-stakes scientific showdown.
It was a showdown.
Frank, with his small comets, versus Donahue with his cometesimals, both waiting with bated breath for Galileo to send back the data.
Who would emerge victorious?
Yeah, who emerged victorious?
Well, here's where the story takes a dramatic turn.
Okay.
Donahue, in his eagerness to prove his theory, made a critical error in his calculations.
Oh, no.
He overestimated the amount of hydrogen that Galileo should detect if his cometesimals were real.
So like a classic case of overconfidence.
Yeah.
So when the data came back from Galileo, it didn't match Donahue's predictions.
It did not. Donahue's theory basically went up in smoke.
Oh, wow.
And while this was obviously a huge blow to him, it inadvertently strengthened Frank's position.
How so?
Because Galileo's observations didn't rule out the existence of small comets. They just ruled out Donahue's bigger cometesimal.
So Frank's theory lived to fight another day.
It did.
But even without Donahue as a competitor, Frank still had a big challenge ahead of him.
What's that?
Finding direct visual evidence.
Visual evidence.
If these small comets are really out there, shouldn't we be able to see them?
Well, you'd think so, wouldn't you?
I mean, we can see other comets, right?
We can, but there's a reason why these things are so hard to spot.
What's that?
Remember, they're small, they're dark, and they're mostly made of ice.
Okay.
They only become visible when sunlight reflects off of them. And even then, it's just this fleeting glimpse.
So it's like trying to catch a snowflake on your tongue in a blizzard.
That's a great analogy.
So how do you even begin to find something like that?
Good question.
You need some kind of super-powered telescope.
Well, you're in luck, because that's exactly what we're going to talk about next.
Okay.
The search for visual confirmation of small comets is a story full of twists and turns, and it takes us from the world of cutting-edge astronomy to, well, let's just say some unexpected places.
Oh, I love a good plot twist.
Me too.
Let's dive into this next chapter and see what Frank and his supporters did to try to capture these cosmic snowballs on camera. Okay, so we've got this scientific mystery on our hands.
We do.
Tiny comets, maybe the size of a house.
Yeah.
Potentially slamming into Earth's atmosphere all the time. And possibly even the source of our oceans.
It's wild.
But seeing is believing, right? How do you even begin to look for something so small and so elusive?
You're talking about finding something that's dark and fast-moving and only visible for a split second when sunlight hits it just right.
Right.
It's like trying to find a needle in a cosmic haystack.
That sounds incredibly challenging. So what did Frank and his supporters do? Give up?
No, they didn't give up.
Or did they come up with some ingenious way to capture these cosmic stealth bombers on film?
They were determined to find proof.
Okay.
And that led them to the world of advanced telescopes and some pretty creative observation techniques. Remember that astronomer Tom Garrels we talked about earlier?
He was the one with the Spacewatch telescope.
That's the one.
Designed to spot faint objects in the night sky.
Exactly. And this is where the story takes another interesting turn.
Okay.
One of Garrels' colleagues, an astronomer named Clayne Yates, became fascinated by this small comet mystery. He was convinced that if these things were real, the Spacewatch telescope might be able to detect them.
So even though Garrels was a skeptic, his own colleague was on Team Small Comet.
It's true.
That's got to make for some interesting office conversations.
We can imagine.
Okay, so Yates, being a persistent scientist, managed to convince Garrels to let him use the telescope.
He did.
To search for these elusive objects. And he even developed a special technique to try to capture them on film.
That's right.
What was this special technique? Did he have to build some kind of super camera or something?
It wasn't about the camera itself.
Okay.
But how he used it.
Right.
Yates knew that these small comets were moving incredibly fast.
Right.
And they were only going to be visible for this tiny fraction of a second. So instead of trying to capture like a clear image of the comet itself, he focused on capturing their movement.
Okay.
He took these extremely short exposures.
Okay.
Just a tiny fraction of a second each.
Okay.
And then analyzed the images for any sign of streaks.
So it's like those photos of race cars where you see a blur of motion instead of a sharp image of the car?
Exactly.
He was looking for those telltale streaks? To prove that something was zipping through the sky.
That's right. And you know what? It worked.
He actually saw them.
Well, not saw in the traditional sense.
Okay.
These weren't the kind of detailed images you'd see in astronomy textbooks.
Yeah.
It was more like visual fingerprints.
Okay.
Just this faint trace of something zipping through the telescope's field of view.
Still, that's incredible.
It is.
It's proof positive that something was out there moving in a way that matched Frank's predictions.
Exactly.
So surely this convinced everyone.
You'd think so, right? But even with this compelling evidence, the debate raged on.
Oh, come on.
Some scientists were swayed by Yates's images, while others remained stubbornly skeptical, just clinging to those old paradigms, familiar explanations.
It's amazing how resistant we can be to new ideas.
I know.
Even when the evidence is staring us right in the face.
It really is. It's like those optical illusions where you see one thing, but then someone points out another image hidden within the first, and you can't believe you didn't see it before.
It's true.
Sometimes we get so fixated on seeing the world in a certain way that we just miss the bigger picture, the hidden truths that are right there waiting to be discovered.
It sounds like Yates wasn't just content with capturing these streaks.
No.
Did he do anything else to try and strengthen his case?
He did to further solidify his findings. He conducted this really ingenious experiment.
Okay.
He pointed the Spacewatch telescope in a direction where Frank's theory predicted NO small comets should be present.
Oh, the classic control experiment.
Exactly.
So what happened? Did he find streaks where there shouldn't be any?
Nope. The results were exactly as Frank's theory predicted.
Wow.
No streaks.
This is amazing.
This finding further supported the idea that the streaks Yates had previously captured were indeed real objects, not just some random noise or some other anomaly.
Okay, so let me get this straight. We've got multiple lines of evidence.
Multiple lines.
Supporting the existence of small comets.
Yeah.
The unique chemical signature of Earth's oceans. The unexplained flashes on the moon.
Right.
The data from classified spy satellites.
Yes.
And now these intriguing images from a reputable observatory using a technique specifically designed to capture these things.
Pretty convincing.
Case closed, right?
You would think so, but the path to scientific acceptance is rarely a straight line.
Oh, really?
Even with all this evidence, the debate continued.
Really?
Some scientists just couldn't let go of the old way of thinking.
Right.
The familiar explanations.
It's like they were clinging to a life raft in the middle of the ocean, refusing to swim to the nearby island.
Right.
Because they were afraid of what they might find there.
That's a powerful image.
So what ultimately happened?
Well,
did Frank ever get the recognition he deserved for his groundbreaking work? Did the scientific community finally come around and accept the existence of small comets?
Well, that's where things get a bit complicated.
Okay.
You see, in science, absolute certainty is a rare thing. There's always room for doubt, for alternative explanations, for further research.
Right.
And that's what makes it so exciting.
So even though Frank's theory isn't universally accepted, it's sparked a whole new area of research.
It has.
A new way of looking at our planet and its place in the cosmos.
Exactly, and that's often how scientific progress happens.
Yeah.
A new idea emerges. It's challenged, debated, tested, refined.
Right.
And even if it's not fully embraced, it opens up these new avenues of inquiry, these new ways of understanding the world around us.
It's like that saying, the best way to predict the future is to invent it.
I like
Frank's small comet theory, whether ultimately proven or disproven, has forced us to rethink what we know about Earth's history.
It has.
The composition of our solar system, and even the possibilities for life beyond our planet.
You got it. And that, in my opinion, is the real legacy of Dr. Louis Frank.
Okay.
He dared to ask the big questions.
Yeah.
To challenge the status quo and to imagine a universe far more dynamic and interconnected than we ever thought possible.
Wow. What an amazing journey.
It has been.
We started with some mysterious dark spots in satellite images.
Yeah.
And we ended up exploring the origins of our oceans, the secrets hidden on the moon, the world of classified spy data, and the ongoing search for evidence of these elusive small comets.
It's pretty amazing.
My mind is officially blown.
Mine too.
A big thank you to you, dear listener, for sharing this incredible collection of sources with us.
Yeah, this was great.
If you enjoyed this deep dive into the world of small comets, be sure to hit that like button and subscribe to the channel.
Yes.
So you never miss an episode.
And remember, keep exploring, keep questioning, and never stop looking up.
That's right.
You never know what wonders you might find.